when you're looking at this example here, solving this equation, some of you are going to be tempted to divide by sine of x, and if you do that, you're going to lose a root. So, in my opinion, that's not the best habit you can get into. Pay very close attention to what your variable's restriction is going to be. You have a domain restriction on these. So you're usually going to be in the first revolution, in this case from 0 to 2 pi, including 0 but not 2 pi. 2 sine squared x minus sine x is equal to 0. This is a lot like what we did a couple chapters ago. We didn't do as much of this as we are in this chapter, but same idea. What do we do next? What do you do next? Factor. So you pull out a sine x, you're left with 2 sine x minus 1 is equal to 0. What do we do here? Sine x equals 0, and 2 sine x minus 1 equals 0. What value of x has a sine equal to 0? Pi over 2 and 3 pi over 2. Over here, you're going to go sine x equals positive 1/2. X is equal pi over 6 and 5 pi over 6. So we have a correction.
Don't the sine of x equals 0 be pi over 10? Pi over 10.
One more time. For sine x equals 0, you don't like these answers. Because what's the order of the coordinates on the points in the unit circle? Cosine comma sine. We want to know where the sine is 0. So where do you want it to be? 0 and pi? How about 2 pi? Can we have 2 pi? So your solution is going to be x equals 0, pi over 6, 5 pi over 6, pi. No? Good. I think Armand's paying attention right now. He's not here. But he may have clicked this on and we've probably already lost him. Really quick? That's as quick as I can go. My computer lags a little, you can see. Everybody okay with this? What do you got going there? What is it? Tiny what? Wow. Too tiny for me to barely see. All right, take a look at this one. Okay, so what do you want to substitute? You have choices, but clearly cos 2x you need to substitute, and you have 3 choices. This is the one that should drive your decision making. You already have a sine x, so what should I replace cos 2x with? 2 sine squared x minus sine x is greater than 0. What? You don't like that?
No. I think cosine squared
Well, you can do that, but then you have to substitute in for cosine squared, one on the sine squared. Okay. So you can multiply through by -1 and get, not that I would normally show this, but we can do this. Don't forget, reverse the inequality. So then it's 2 sine squared x plus sine x minus 1 is less than 0. How's this going to factor? Now you get a sum. If it's equal to 0, it's not as critical to have to think through what's going to happen. So if we say, okay, 2 sine x minus 1 is equal to 0. We'll come back to the inequality in a second. You're going to get the sine of x is equal to a half. What is x going to be? Pi over 6, and what was it? 5 pi over 6. Dan, do you think it means root 2 over 2? Yeah. Okay, and then when we solve the other one, sine x plus 1 equals 0, sine x equals -1. So x is going to be the sine inverse of -1. Where's the sine equal to -1? 3 pi over 2. But it's not an equation. Yeah, you're looking at something times something has to be less than 0. So our situation is going to depend upon 2 sine x minus 1 and sine x plus 1. How are those values going to appear? What has to be true about this and this in order to make this true? Okay, one has to be negative and the other has to be positive. So you have to look at those situations. When is this going to be negative and when is this going to be positive? When is 2 sine x minus 1 going to be less than 0? Okay. And what you want to look at, potentially, since we're talking about the sine curve, it might be helpful for you to realize what you're looking at. So when we do, excuse me, 2 sine x minus 1, where is 2 sine x minus 1 going to be negative? So we could say, okay, let's think about this as sine x has to be smaller than a half. Has to be less than a half. Where is the sine of x going to be less than a half? Where is the sine of x going to be less than a half? Well, when you look at your boundaries, it's equal to a half at pi over 6. So here we'll call this pi over 6, maybe right here. And over here, 5 pi over 6. So we can say that this is the half, and this is a half. So you're looking at the range, or the location would be right here, and right here on the top half of this. So between 0 and pi over 6, and from 5 pi over 6 to pi, you're going to have a 2 sine x minus 1 is going to be less than. This one has to be sine x plus 1 is less than 0. So that the sine of x is got to be less than negative 1. What do you know about that? Think about that again. When would the sine of x be less than negative 1? We have commitment issues here, don't we? Always, never, I don't know. Look at your graph. Here's negative 1. When is the value of the sine less than negative 1? Never. So there's no way this can be a negative, and this, or what did we say? This, oh sorry, we want this one to be the positive, right? Is that what we said? Yeah, we want this to be greater than negative 1. So we have a positive and a negative. We did the negative already. So here's where, what did we say, 3 pi over 2? Isn't? Here's what we did first. 2 sine x minus 1. We're going to call this one the negative. So that means it's going to be less than 0. And when that's true, sine x will be less than a half. And where that occurs is here and here, at the upper side. Okay? When we look here, in quadrants 3 and 4, we want to be greater than negative 1. To be sine x plus 1 is greater than 0. So sine x has to be greater than negative 1. That's going to give you positive value. Where is that? That's from pi to 3 pi over 2, not including, and 3 pi over 2 to 2 pi, not including. So that set of circumstances will make this true. Then you have to flip it. Do you see how complicated this becomes? We're not going to do these on the evaluations, where you have to say this is positive, this is negative. Then you have to reverse them and say this one's the negative, this one's the positive. To find all those regions, that becomes pretty arduous. It would work out too. Eventually, you'd still divide out the negative. It just meant factoring when the first term is negative. If you have negative 2 sine x minus sine x plus 1, it will still work out. You should still get to the half in the negative 1. If you didn't factor it correctly. But my golden rule for factoring for me, I never want this to be negative. It makes me have to work too hard. And that thinking thing is not in my, what I want to do most. Okay, so even though we're showing you the inequality, we're really not going to do the inequalities on the evaluations. What I wanted you to see is that you need a positive and a negative to make something negative. If this was greater than 0, you would either have to have positive, positive, negative, negative. And you'd still have 2 sets of situations to worry about. In calculus, they're going to do a lot more. Well, they're going to do that, so you'll worry about that in calculus. Try this one. So the answer is I didn't finish it because we have to go through a whole nother series. Switching the signs. Yeah, listen. All right, so what are we going to replace cos 2x with? So you want to bring everybody to the right. No, I don't. What do you want to do? 2 sine squared x minus sine x. Well, Sophia did it, and then she did it again when she said it out loud. What? How does it factor? minus 1. Where does the sine of x equal 0? And 2 sine x minus 1 equals 0. So the sine of x, again, we're back to 1/2. 5/6, 5/6. You seem to like those as answers. They will be. It's not about the answers. Right, Justin? You know what Justin's t-shirt says? Work is overrated. No, it doesn't. It says work is overrated. I'm going to go take it now. Hey, try this one. What are we going to substitute for cos 2 theta? Cos squared theta minus 1 equals cos theta. You can see these examples are all pretty much the same, except for we've got one switch coming up. When you factor 2 cos theta minus 1 cos theta, oh, we want a minus in the middle here, so plus minus. Cos theta plus 1 equals 0. Where is the cosine of theta equal to negative 1/2? In degrees now. So theta is going to equal 120 and 240. Over here, cos theta minus 1 equals 0. Where is the cosine of theta equal to 1? What is it? The cosine. Are you messing with me today? Bless you. Except that I would just think of it as, where is the cosine of 1/2? That's your reference alpha. That's at 60 degrees. So in quadrant, NU2, all students take calculus. And you want to be for cosine negative, quadrant 2 and quadrant 3. 180 minus 60 is 120. 180 plus 60 is 240. Well, where is the cosine equal to 1?
0 degrees, and then also.
I agree with you, but it's out of bounds. So you have to stay in bounds, and they're going to set the boundaries for you. So try this one. At least 6. I would say 6. Okay, so what do you want to substitute for the cos 2x? Cos 2x, what are you going to substitute? 2 cos squared x minus 1 plus cos x is equal to 2. When you distribute, this is okay to distribute here. 6 cos squared x minus 3 plus cos x equals 2. That's just the, sorry. 6 cos squared x plus cos x. When you subtract 2, you're going to have a minus 5 here equals 0. How's it back there? Everybody okay with that? So now you have 6 cos x minus 5 equals 0. So cosine of x equals 5 over 6. Just the heck out of me. Bust out the technology. On this homework, though, or in this example for sure, and we are in radians. So make sure your calculator's in radians here. So 0.586 and 5.697. So those are the two that will get you cos x equals 5 over 6. The other one is cos x plus 1 equals 0. Cos x equals negative 1. So x has to be 5. There are, but we're not finding it. Everybody okay on that one?
Yes.
Those 5 examples all pretty much the same. The inequality one makes it a little bit harder. What you ultimately you can either do positive negatives or you can plus minus test it. So this last one, okay, this last one's going to be a little bit trickier. Now you might be tempted to switch out the sine 2 theta. It's really not necessary. How can we solve this? So the sine of 2 theta is going to equal a half. With 2, like this. Let's just do 2 theta equals sine inverse of a half. Well, hopefully not for sine inverse of a half. And we're in degrees. 30 degrees or... No. I didn't mean or. Let's switch to a different language. Give me the other angle. 150, right? If you're not sure why it's 150, we're doing all students take calculus. So we're positive in quadrants 1 and 2. Once you find the quadrant 1, to get quadrant 2, it's 180 minus 3. Daniel, yeah? Yeah. You need to get some rest, man. So what is theta going to equal here? 15 degrees. And theta is going to equal 75 degrees. When you're doing sine of 2 theta, what is the 2 doing for us? It's doing what to the period? So it's giving us more solutions. It's making the period into a half the size. What's the period of sine theta? 360, so half that period, 180. So we're going to have a period of 180 now for sine 2 theta. If we add 180 to the 15, theta could also equal 195 degrees. If you add 180 again, you're out of bounds. If you add 180 to the 75 degrees, what is it? Thank you. I used post-math revolution numbers. So your values for theta, you end up with 4 values for theta again. But rather than substituting in and having to use a squared, we can use the 2 theta as long as we don't have any other functions to worry about. Well, if it's 2 theta, it's half the period. The period's 360, half is 180. If it was 3 theta, you'd add 120. If it was 4 theta, you'd add 90. Over and over and over again until you go out of bounds. Everybody good here? So this is what you're going to be working with.